The models are really good at certain things, but they're not good at code-based architecture, and if you leave them unattended, they will make a big mess.
Welcome to the Agentic Review, the podcast where we explore what good code really means in the age of AI software development.
I'm Nnenna Ndukwe, Developer Relations Lead.
And I'm Itamar Friedman, the co-founder and CEO of Kodo.
So let's get into it.
Today, we're joined by Dex, CEO and co-founder of HumanLayer, a YC-backed AI context lab and the author of the 12-Factor Agents Manifesto, which has become one of the most widely referenced framework for building reliable AI agents in production.
Dex coined the term context engineering and spent nearly 7 years at Replicated learning how enterprises actually adopt software in lockdown environments, and is now on a very public mission to close the gap between what AI agents promise and what they actually ship.
So Dex, without further ado, I didn't mention your family names because I feel like Dex is like Madonna. Please share more. Welcome to the show, and please tell us more about yourself, especially those things that we have missed.
No, I love that. Thank you. I'm super stoked to be here and appreciate the invitation. I've never heard it in that exact phrasing, but yeah, very public mission to close the gap between what we were told agents can do and what they can actually do. And that comes from my own journey, right? Like a year ago, we published the 12-Factor Agents essay or paper or manifesto, if you want to call it that. And it was kind of my journey of like getting sucked into the AI hype machine and building for this whole ecosystem that if you were paying attention to most of what was happening online, you were told, hey, this is the future. This is how it's going to be done. It's going to be like, I'm not going to name specific names, but a lot of open source frameworks that were very, very popular. And the kind of promise was like, hey, if you build for this ecosystem, then you will be able to distribute to lots and lots of people, and enterprise will be able to use your stuff. It was kind of like building to a standard that hadn't actually been adopted yet. And then we actually went to go sell tools that were built for that ecosystem. And we found out that everybody building production AI and like actually selling 6-figure contracts to enterprises wasn't actually building in that way and wasn't using any of that stuff because it didn't really work. And it was all just hype. And so I'm now like, okay, I got burned by that. How can I share the lessons? And then that's just been like, do that and then just repeat every 2 or 3 months, go get in the trenches with customers, learn stuff. And then teach people about it and try to save folks from hitting all of the mistakes and landmines that we hit in the last 6 months or year or whatever it is.
Yeah, I think that's awesome because I felt like that was a big part of the energy, the build in public, and the honesty that you've showed for your talk at AI Engineer Miami. So I think would love to, for you to explain or give a recap of how that also went and what it was about.
And were you referring to AutoGPT? I'm not going to get you.
No, it wasn't AutoGPT. It was Crew AI and LangChain, and basically all of the things now that are, I don't know, people are getting completely obsessed with harness engineering, and it's like, okay, 80% of what you guys are excited about is a thing that people have been doing since 2023, which is like agent calling tools in a loop, and no one is focused on the cool part of harness engineering, which is like RLing a model on the harness that it's built for. Anyways, you asked about Miami.
Yes. Yeah. A recap of what you spoke about, because, I was there, I saw it, and then also, the internet saw it too. So there was a lot of excitement and discussion about some of your, I guess, controversial slides about reading the code.
And if people saw it, yeah. I apologize. And if you haven't seen it yet, I apologize in advance. We gave a talk back in November that was really, really popular. I think it has like 500,000 views on YouTube, which was our like RPI, research plan implement system. And we had been rolling that out to companies of all sizes, from small startups to Fortune 500, thousands of engineers. And in that kind of 2, 3, 4 month period, we learned a lot about what we got wrong about it in terms of like the difference between building for power users and building for average users who can't be bothered, the difference between like building, again, like what is needed to take something from one person's workstation and workflow and make it work across everybody's workstation and workflow, and like how do you basically as the models change in character, how do you do context engineering, split your workflow up into more smaller sessions to get better results and to kind of raise the ceiling about what is the hardest problem you can solve. Although I will say, I guess the most exciting part for most people, or controversial perhaps, was like in August, we were like, stop reading the code, just write really good specs and let the model cook and like hope that it's smart enough and you'll be fine. And Ralph Wiggum made an entire programming language in June and like yada, yada, yada. And then we did that for 5-ish months. And then we suddenly were like, you know what? This code is terrible and it's really hard to work in. And like, we're going to go back to reading it. And we like ripped out and replaced almost all of our product and like rebuilt it from scratch. And I tell you, my co-founder was in VS Code, not even Cursor, typing every character by hand for about 2 weeks to like make sure that the bones of the project were really, really good. And that was around November, December. What basically happened since then was like December, the Opus 4.5 thing happened, and way more people like Opus 4.5. I actually think is not as smart a model as Opus 4.1, but it was a little bit faster and it was better for like people who didn't know what they were doing, and that's what and it was much cheaper, and they gave everybody up like double limits over the holidays, and the whole thing blew up, and everyone got really into it. And then Strong DM published their like lights off software factory. We're gonna build a bunch of products. Dark factory. No one's going to write the code. No one's going to read the code. The only thing humans are allowed to interact with is like tickets and specs, but no one reads the code. And I'm like,
so until now you described like Pendulum, like we were there, we went back and back again.
So
like
no, so like we were there in August, and it took us about 4 or 5 months to swing back to like, nope, the models are really good at certain things, but they're not good at code-based architecture. And if you leave them unattended, they will make a big mess. And the whole rest of the industry is like swinging. Maybe they're higher up to the left or maybe they're further down, but the rest of the industry is like, they just hit this point of like, hey, let's see, like, what if we just don't read the code? And that was in December, January. And you actually see now in like April, like in the last week or two, there is a huge outpouring of people, at least on Twitter, is like, oh, actually, like, we're going to go back to reading the code. There's kind of this like 5 month, it takes you 5 months from like, we don't read the code anymore to like, damn, you know what? We actually can't go 10 times faster. Let's go back. Let's guarantee stability. And then maybe we can like incrementally go up to like 2 or 3 times faster.
Yeah. As the CEO and co-founder of Kodo, I am in a strike of like 1 or 2 PRs a day. Don't worry, I'm not touching like core functionality. I'm leaving that for the engineering team, but it's very important for me to do day to day. And I feel like I'm doing that Pendulum like every day or so. And it is kind of converging. Like sometimes I find myself like being much better. And what I think you described in some of your talks, like doing the research part prior to the coding. Like I do know what to ask for the research. Like, hey, look on the software patterns there. Look on the design patterns there. Look like but then like I feel like I have a really good spec, and in many cases like I'm feeling I didn't write one human token in the code itself, and then like I get maybe a little bit too confident, and then I kind of find myself like opening up ER that probably could have half the size or so, because I didn't think thoroughly, for example, on the architecture, like you mentioned, although I gave the prompt. So I'm kind of like having this pendulum and myself almost daily, and maybe that leads to like kind of like a tagline. I think you mentioned that we are in an asymmetric war on Slop. Is that related? And like, who's actually winning right now?
Yeah, so that was actually from Swix's talk in November. He gave like the opening talk for AI Engineer Code, and it was kind of like the war on Slop. And what he encouraged, it was like a very short talk, but he just encouraged the entire audience to just like, hey, when your boss asks you to ship this, even though you know it's not good, like, what do you say? No more Slop. When you want to publish the blog post, but you know it's no more Slop. Like that is like 2026 has to be the year where we pull back and we say no more Slop. And he pulled it up. I forget the original quote, but you can go watch the talk. But he was basically like I think the original word was bullshit. It was like the work required to like combat and refute bullshit is like 100 times harder than the work it is to produce it. And I think Slop has the same thing of like, it's an asymmetric war where like, it's basically almost free for people to generate bullshit comments on LinkedIn or like generate terrible trash code that's not going to be usable in 3 months or whatever it is. And it's much harder to defend against these things. I mean, the OpenClaw guys and the Pi team, they're all having this issue where they're drowning in PRs from bots that are terrible. And it's way more work for them to kind of like just keep people happy and keep the reputation okay and actually like let through the good PRs than it is for all of the people who are just like barraging the entire repo with garbage.
Yeah. So what do you think, by the way, on AI for code review? And after that, Nnenna, I'd love to hear your thoughts about it.
AI for code review, I'm kind of on the fence. I've like publicly kind of talked about like it's very easy to accidentally like have AI for code review be kind of useless. Like obviously the most naive one is like, hey, GPT, review my coworker's PR and tell me everything that's wrong with it. And it's like, okay, it's going to come up with a list of like 30 issues. If you're like, hey, is this PR good? You're going to get the opposite. You're going to be like, oh yeah, it's comprehensive. It's got unit tests. It's like fully, it does the whole thing. It's like, it's way too easy to oversteer these models to have opinions on things. And so like for code review specifically, I think like there are ways to do it well. And it's like part of it, I've seen code review bots do things like explain the PR, like explain the surface and basically like compress it down where instead of reading thousands of lines of code, I'm reading 100 or 200 lines of markdown, and that at least grounds me before I go look. I know which parts I actually want to go check. But it's also like doing classifications is really easy. Like if you ask the model, is it X or Y? It's pretty good at saying X or Y, but it's up to you to apply a value function to those things. Like you can't ask a model scale of 1 to 100, how good is this PR? But you could say, does it have unit tests? Do the unit tests actually cover the thing that matters? And like answer all those, and then like you create the score deterministically based on like the model doesn't know what you can't leak the understanding of what is good or bad into the model because then it's going to try to tell you what you want to hear. Does that make sense?
Yeah, so there's like a bias is what you're saying, or I guess there needs to be intentional blindness or independence in that process.
Yeah. I don't know, Itamar, what's your take?
Yeah, of course. So first of all, of course, we're biased at Kodo. We're the AI code review and governance platform. So we are noticing that the models themselves as an LLMs are very, they follow instructions. They're trained to follow instructions, and therefore, if you give them that bias of like, hey, can you check if this actually works and it's really, really wonderful, then they will tell you, yes, this is super wonderful. Although I do see like them getting better on that, but still, of course. But I think like companies, and it's not only Kodo, just I don't want, it's not a commercial for Kodo, like that are focused on building like AI code review systems that like objectivity, that opinion, like building opinionated agents is exactly the job of the tool, to take like different sources of information, take different like consideration, actually 9 types: architecture, performance, maintainability, etc., and bake it into the agent to be very thoughtful about it is what we do. And I think that's like maybe a little bit like the difference is that if you ask, have you ever seen Claude Code tell you, no, I'm not going to do this for you. I'm not completing this for you. It's not how it's built, right? Like, correct me if I'm wrong. If AI code review, they're built the other way around. Like,
I tried to get Claude Code to help me play poker with my buddies last night by taking screenshots of the browser and telling me what's going on, and it outright refused to help me gamble. So I had to convince it was a play money game.
Yeah, there's certain things they won't let me do. I think I always have that problem with Gemini when I'm like, generate this image, and it just gets so sensitive, which is just ridiculous. But well, actually, when Itamar was mentioning the whole code review, different types of specialized agents, and it made me think about like the whole context concept that we really talk about a lot here in the context engine that we have, and how there's different context types that you need to bring in to refine and improve the actual code review system, like customized to teams and developers. And you're a part of how the phrase context engineering exists today. And I'm like curious, like, do you think that this has been maybe overused? The term has been, I guess, diluted in some way since then?
It's interesting. I I want to say no. I mean, one of the things that actually, like, I was going back and watching, I do a podcast with my buddy Vibov called AI That Works. And he's actually one of the, like, the person I spent, the reason, the way I came up with 12 factor agents and context engineering, a lot of it was just spending way too much time with Vibov. He's one of the best kind of thinkers on, one of the best thinkers on AI systems and AI pipelines. And how do you get a small model to perform as well as a big model, or how do you get a big model to perform way better on a specific task? He's just, like, I think one of the best thinkers on those kinds of things. And I was watching an old podcast from like a year ago about 12. I was like, you know what? I still believe almost all of this. So either I'm getting sloppy and I've left myself behind, or it's one of those things that is like, I think the takeaway there would be like, as long as you are working with transformer based LLMs, yes, the models will get smarter and they'll be able to do a harder task with less context engineering required. You can just YOLO prompt it and it'll be able to do it as the models get smarter. But overall, like, whatever the task is, if you're able to apply context engineering to it, you will always be able to get better results than someone who is just YOLO prompting.
Yeah, that's a very clear like difference. Go ahead, Itamar.
Yeah, so I actually +1 on Dex, and I double down. I think like if context engineering was needed like a year or two ago, I think now it's actually one of the biggest moats. Like, of course, workflow, etc. But the more agents are better in tool usage and developing their workflow as they go, which is getting better and better. I'm not saying like you should not do workflow, you should. But the more they're better in designing and building their workflow, one of the most important concepts in building the solution is the context. And it's not simply like throwing everything into files. Like file system is all you need. I'll just like generate 1,000 files, give each one of them a header, and that's it. You need to properly engineer a context. Like, what would you say about that?
Yeah, again, like, agentic search is great. Tools in a loop is great. It's much better than it was a year ago. But like, even if you're doing a agentic tools in a loop, like, the smaller you can make those tool cycles, the more you can break down, like, hey, you agent, rather than being responsible for taking in 100 different types of inputs and calling 1,000 different tools, if you can break that down into like, okay, classify the input and hand it to one of 20 different agents or whatever it is, where each agent only has like 30 tools, it becomes more brittle, right? It's a trade-off. Like, agent with tools in a loop is like, okay, give it as many tools as possible, or I don't know, 1,000 is overkill. But like, the point is like, the more open it is, the more different things you can solve. But the more specific you make it, is like the better you can solve those specific things.
So what I'm actually hearing from you is that you're kind of like still arguing that building workflows, I think there's two topics here. First of all, I'm hearing from you that think like building workflows, like step 1, classify, step 2, according to choose the next agent or so, etc., is still very important. Do you think, am I right? Like, that's what you're saying, and do you think it's still going to be like that? And the second thing, I think like a context is one of those tools. Context is one of those agents, and like. Would you treat it as the same? Like, you feel the same category as another agent, or would you give it a treatment by itself?
I mean, maybe this is where the term is starting to get a little overloaded. Then is like, context can mean, when I say context engineering, I mean like, what do you deterministically push into the prompt, or how are you controlling and being mindful of like which tools you steer the agent to get context. But the word context has become a little bit bigger with MCP and Model Context Protocol. If you open up the Claude desktop app, they have a context section, and the context section says, it's a list of the MCPs and tool sets you have connected. And so some people call context, and they refer to the bundle of things you have given the model access to, which I would call tools, but or tools or integrations or harness or whatever it is. So when I say context engineering, I'm thinking more at the granular level of like a single call that is going to the LLM, whether it's the initial like system prompt tools user message, or it's turn 50 of an agentic conversation. You're still caring about like every token in is the only thing that influences like whether the token you get back, which is a tool call to edit a file, or to go look something up in a knowledge base, or to execute a dangerous operation, whatever it is, like that, those tokens coming back, the only thing that controls how good they are and how likely they are to be correct is the tokens you're putting into the model at that point of the workflow, or that point of the agent. I have a question.
Go ahead.
Relevant. You all do a lot of context engineering. How do you think about the bitter lesson and like this challenge of like, hey, we do a bunch of context engineering and then a new model comes out and actually it's like, oh, we can just prompt it and it will go gather its own context or figure it out itself. And now all the code we wrote is irrelevant.
It's much clearer now. About context. First of all, I am absorbing your definition. I think I only now got it, to be frank. Like, you're saying the context engine is more of a concept where every time you're making an LLM call, you want to make sure you're organizing what is the context you're putting into it that is more deterministic, that is steering into directions that you want the engineer, the LLM and the agent to go through. I'm with you on that. I'm mixing as well the concept of memory or database or etc. And that's where at least for Coda, we think it's critical to accumulate that. So, and really roughly speaking, is the context engineering that is just in time, like on inference time. And there is the sleep time compute that is happening to gather that context. And that's part of what we call context engineering. Maybe that's something that we should reframe as memory or etc. or some engineering work. And the reason it's so important is because when you're doing AI code review, just as an example of AI software development and the era of AI, is that like you want to bring the subjectivity that teams and individual have into the review. Quality is subjective. Like, there are some global agreement about what is good and bad in code, but a lot depends on the specific repo and a specific use case, and even on specific people that are owning the repo, and that's how they want it if they want to take ownership. And then like we're gathering a lot of context from PR discussions, from user interactions, and we want to accumulate that over time and create that tool that is in charge to enrich the context with history that was accumulated and agreed upon. At least for us, that's how we include that in a context engine, but maybe the right definition is context engineering and memory or a collection or so. I'd love to hear your thought about it.
Yeah, I mean, memory is a really interesting one. And like, I think a lot of the really sophisticated memory implementations I've seen are quite deterministic. Like, they're not tool based at all. Like, some of the early memory things where like agent could like record memory and then search memories, and it was a very simple like RAG based thing. And then I've seen some really sophisticated ones where it's like every time a conversation ends, it gets handed to another model to do inference on that conversation and compact it into memories. And then you have sleep time compute, which is like basically doing that. They call it like decaying resolution memory, where you have like summaries for the last 14 days, and then you have weekly summaries for the preceding 6 weeks, and then you have monthly summaries going back in time forever. And every night you take the oldest day summary and compact it into the last week. And you're constantly like shifting and resummarizing this whole set. And then that all just gets deterministically injected in. So the model who is doing the conversation has no way to modify its own memory. It is deterministic what gets injected in, and the way it gets compacted and recorded is a completely separate context window. So you're not asking the model who's trying to help the user with their task to also think about like this complex thing of like make really good choices about what gets recorded into memory. Like, it's just a completely separate prompt with a separate model that is making all those decisions. I don't know if that's an answer to your question, but
Exactly. That's like I agree about that. I think the purpose of a memory is to reduce variance. I can't really like see how it is like completely deterministic, but the whole idea is grounding with information that was over time accumulated and agreed upon during like computation that is spent before inference, and user interfaces that are meant to like create alignment, etc. Like I think that's completely like awesome, and I think like I believe that it's still like a big portion of advancement that we're going to see in the future is around memory and context engineering, etc. In that sense.
Yeah, I've seen a lot of folks actually talk about memory now more than ever. I think there's one guy who's like a director of developer relations at Oracle, and that is like the main push is memory.
We'll see where it goes. Someone pulled me over on the floor at React Miami, AI Engineer Miami, and he was talking to somebody, and he was just like, "Hey, Dex, come over here." I was like, "What do you think about memory for AI agents?" And I was like, "Well, I think there's a lot of interesting off-the-shelf memory systems. I think if you pull an off-the-shelf memory system, it's going to be similar to an off-the-shelf agent, like agent SDK or agent harness, where like if you grab the thing off the shelf, it'll get you to 80% really fast. And then once you hit a wall, you're going to end up reverse engineering the whole thing to figure out like, okay, where do these tools get injected? Where does this come from? How are subagents called? And eventually you're going to just end up building it yourself. And so I think any good implementation of memory, like we haven't found the right primitives because everything is changing so fast and there's so many different approaches that work well that like I admire the people working in the memory field trying to build like horizontal tooling for agent memory. It's must be incredibly hard because every app I've seen that is like high quality actually selling same thing with context engineering and agents is like if you are actually building a really high quality product, you are in the weeds really engineering every single token in and out of your memory system to make sure that it solves your exact use case.
Totally agree. So it looks like you have a lot of experience, obviously, in building like real world system at scales, going to production. You mentioned working with Fortune 500, etc. I'd love to hear more about that. Like our audience love to hear like how to bring, agents to production, and it could be from off, like how do you do like authentication with agents, like different aspects of privacy, etc. Whatever you like to share in that front will be interesting.
So we talked about I guess my question is like what about PR reviews when you go to sell someone AI code reviews, like what is the pain point that y'all are most addressing? Because I'm really curious about like how people find their way to, I mean, obviously like anything that AI can do that a human was doing before that AI can do as well or almost as well is like great, hell yeah, like spend tokens on that instead of spending human hours. But I'm curious, like when people, that's like, okay, let me just be more efficient everywhere. That's the vitamin category. Like for whom is your product a painkiller? And like what is the pain that you're solving? For whom is like AI code review a burning fire? And they're like, we have to get this in ASAP.
So code quality is a $1 trillion problem from the time of ancient Greek. But I think so. It was always a problem. Like you don't want less issues in production. You don't want to go back and again to fix like issues and bugs and technical debt and etc. But the thing is that if you want to cross some levels of velocity, then you have to treat that bottleneck in a more serious way. Like in once you get to a point where you're opening more PRs than your human developers can review, then and they cannot go line by line, you want to increase the automation on quality, and then it's not just like a vitamin. It's a painkiller. Now that requires like the stakeholders supposedly that you're solving for is the technical reviewing that is reviewing one PR, but actually you're solving also for the dev team, the organization, to collect their tribal knowledge over time. And that's why the idea about memory is very important for AI code review. You're solving for the entire team to collect their tribal knowledge over time, such that eventually the AI code review could provide feedback at the level of not only a senior developer, but a senior developer that has some tenure, some experience in your company, in your team. And that's not trivial to do. And the last thing is that once those PRs like are in scale, like it's not like in some of our clients and the customers, and we're not only for us, for others, like we're seeing like every 2 months 2x amount of PRs. It's not only about automating that review per pull request. It's also looking on all the pull requests as a whole. Like as a tech lead, as a manager, I want to understand how are my rules are doing, which rule is actually being violated and caught, and which rule is not, etc. So that holistic view of what extra guardrails that you could put to further automate across your teams, and how one team is doing versus the other is like superpowers that we didn't have before. Like, tell me how many companies you know have the level of policies of Uber or Google, and they're actually being followed. You couldn't do that.
Yeah.
And now it's actually you must. So this is like how we see it, and the importance, and the market is like capturing on that, like where we're seeing like it crossed the visionary to early adopters, and it's getting to the mass market. Like by the end of 2026, I think that at least half of those clients are having code generation and using them to the harnessing it to not to extreme but really well, would also have an AI code review tool or two. That's how we're seeing it.
Yeah. So I mean, yeah, I think your point about bottleneck is really interesting. Is like we have had processes. We did this RPI thing, and one of the first things we did back in, I want to say like September, is we built like a software factory version of RPI, where like you create a linear ticket and you assign it to some agent, and it will take it through the RPI process. But instead of just being like dev to code review, it had like research in progress, research and review, plan in progress, plan and review, and then only then it would go to in dev. And so we would go through a bunch of like, we'd run through the backlog and we'd find all the small stuff, and we'd just be like, cool, like that's easy. Just assign that to the agent. Just assign it to the, we go through and like, 80% of our things would just assign to the agent. It would like flow through. We check it at the end. And what we realized was all we had done was converted our backlog from, 40 tickets of like to do to 40 tickets of research and review. And so it's like, no matter what the bottleneck is, whether it's the research or the design or the plan or the code review, you're just shifting the bottleneck to some other place where it's like, okay, cool, the agent can do all the coding, but we still have to decide if this is the right approach, if the code is high quality, all of this. And it's probably faster, but it's like, yeah, we're drowning in PRs. Is a common problem I hear. And my one counterpoint here is I will push us to like acknowledge as an industry probably is that you actually don't have too many PRs. What you have is too many bad PRs. If the PR is perfect, it's actually a joy to review. And the problem is even if a PR only needs like, let's say it needs like 20% rework, which is in the age of AI, it's usually more like 50% or more, or it's just complete crap. If you just gave it to an agent to YOLO it through for any like reasonable sized task, it's not like a little tiny copy change or something. It's like usually needs. And so if it's a human writing the code or an agent writing the code, it's always a like intellectual burden on the reviewer. And then if a human is behind it, then it's an intellectual burden on the reviewer and the submitter to work through that review, even if it's just 20%, significant burden. And if it's two humans, it's also a significant like emotional burden, whether the PM wrote the ticket and the engineer is reviewing it or whatever it is. And so what we have built internally is we don't do a ton of like AI code review yet. We're focused more on like, what can we do upstream from the code being written to make sure that most of the PRs that come through need less than 5% rework, like that the decisions are made, and we've kind of aligned on a team as a team on like a 200 line markdown doc for a 2000 line code change, which is like much higher leverage. So we have this design doc as part of our process, which is like kind of in the middle. It happens after the research, but before the plan gets written. And it's like the very high level, here's the end state architecture, here's all the decisions I've made about how it's going to look. we don't require, is an optional review step in our process. We don't require people to get their design reviews before they go to pull request. We're a 3-person team, so we can kind of be a little bit more loose there. But I am incentivized. I almost always send Kyle my design docs, my CTO, because I would rather have him tear apart a 200-line markdown doc. Easier for him to do, easier for me to go change before I've written all the code and gotten the test passing and like polished it and gotten it how now I'm attached to it. And now if I need to change it, I'm like, oh fuck, I don't want to change it. And now if someone is asking for changes, like, oh, now I got to ask him to change it. You know what I mean? And so it's like, how do you optimize your SDLC, and can you apply AI upstream from the code review itself in order to like ensure that you have fewer surprises at PR time and all of your PRs are almost perfect?
Yeah, that is like literally what a big part of my talk was about at AI Engineer Miami. I was like, okay, if people can just walk away remembering anything, I'm just like earlier, like code quality practices, like early and often, just to reduce all of the stress or all of the problems that could arise later on down the line at code review. And there's many different ways to do that, and what you just described was definitely one of them. On top of and underneath that layer, just like the way in which you are leveraging AI and the context. Yeah,
And I mean, this is what's so exciting about, hey, we're going to build a context and memory layer on, like, let's capture the human taste and judgment from all the senior engineers in your org and then expose that to an AI that can then go apply it to a problem. Is like, that same knowledge is just as valuable in the design stage as it is, maybe even more valuable in the design stage than it is in the code review stage.
One, I agree. Two, but I'll explain. Like, I think, like, if we're thinking about like what you're saying, which I completely agree with, about like the value of spending more time on the research and the spec, if we can call it this way, makes sense. Actually, even we can claim that this is better engineering from the get-go, regardless to AI. But to some extent, if you go to the spec into the smallest details there are, it's basically coding, right? So there, like, if you mention for every part which rules it needs to follow, which like error handling it needs to catch at the level of like if and else, then you're writing code. So then, like, practically you like you're adding another stage. Like, if you're looking on the future, I am adding and suggesting that you presented how the future should look like on putting efforts into upstream. At the same time, we should put efforts in the downstream, not in reviewing, but rather writing down what are our rules, what are our guidelines, how are we expecting AI for code review to review the code. So eventually, not only that we'll get much better percentage of good quality code, but also we'll get much better percentage of high quality review by AI, and then we streamline. The perfect like case is where we did a really proper job in writing the spec and proper job and writing rules and guidelines and skill in reviewing, having this multi-system agent for review, and then we're left with the AI raising us like issues that needs human attention, etc. I'm not claiming for it right now, but I actually do think we can get to this within 12 months or so. That's how I see it.
So this is why I hate the word spec, is because you have said spec and meant a completely different thing. I don't use the word spec because the word spec is completely semantically diffused. For some people, it's like a PRD. For some people, it's a very detailed PRD. For some people, it is like something that is like or like what you talked about, of like down to the if else level of like it's basically just code written in English. Or, I mean, we had this problem. I talked about this as AI engineer as well. We were reviewing the plan file, and the plan was 1,000 lines of like line by line. Here's the files we're going to change, what order we're going to change them in. And then we would review those. People would review those, and then they would have to go write the code. And there would be a couple surprises. And so the end code state would be 10, 20% different from what was in the plan, either because it was poorly specified or because it was wrong or because there was a type error, whatever it is. And then you're reviewing the code. And so like, any spec that is, you're looking for leverage, right? Any specification that's going to take the same amount to read as the code itself, just read the code. But if you can find a type of document that describes what you want at a 20% compression ratio to the actual code, then you have leverage, because then you're making decisions at a higher level. And so I like specification. I don't know. I'm making 3 comments in one go, but like, yes, I agree with what you're saying of like, if your markdown is too detailed, then no one should read it. You should just read the code that comes out the other end.
I think one of the things I wanted to talk to you about is like, is this about what type of at an engineering organization or a company, what type of responsibility would senior engineers or those above them in engineering leadership have when it comes to the closing the gap of any AI slop or AI code quality issues? Like who and who is responsible for that apart from the actual engineer in their day-to-day life? And in which ways do you think that they're responsible?
This one's tricky because in the old world, you could say like, okay, if you ship a bug, you have to fix it. You own it, right? Like as a senior engineer, it's not my job to go clean up after the mistakes of the junior engineers. It's my job to educate and mentor and coach them and hold them accountable so that they actually learn. And nowadays, it's like, okay, if there's a bug, I fix it. And like, there's like this new meta layer, which is like, am I shipping more bugs right? It's like, okay, cool. There's a bug. I told the AI to fix it. To fix it, we shipped it. Oh, but I broke something else. And there's a bug and I told the AI to fix it and it shipped it. And like, I'm taking ownership of the things that break, but I'm not taking ownership of like the velocity of actual valuable new work, or the amount of code base churn where we're like, okay, I make a change here, and that tends historically, that has been the job of architects and senior engineers, is like, okay, how can we design the system and how can we put guardrails, the code review or whatever, using my like accumulated taste and judgment from 10 years of writing software and writing bad software and getting paged at 3 a.m. and seeing all the patterns that I hate, and making sure that we don't introduce those, to like, how do I hold people accountable for noticing that higher up layer? It's almost like, as a junior engineer, your job is now to wear the senior engineering hat of like, how do I make the system safer so that when I prompt the model that it just goes. And like, maybe everybody is a software factory engineer now, but it's like, as a junior engineer, you don't have that accumulated, like Mario Zechner, who's the Pi guy, has this thing of like, you should embrace the friction and you should slow down, because the things that are hard to understand, if you don't understand them and you just let the model YOLO it, then you never learn. The friction is the part of the process where you learn.
Yeah, completely agree. I feel like I don't really, I feel like when we talk about engineers and what they need to do with AI, and what you just said about the architects, I'm just like, oh yeah, like, what are we talking about? What architects are responsible for now in this age? Because we talk about software engineers co-architecting, and I say this myself, co-architecting with like Codex or Claude Code on when we're in planning mode or whatnot. But now, like, what does an architect do moving forward in this? I mean, I don't know. I'm curious to hear both of y'all's thoughts on this.
Sure, I could start short. I think like it's actually writing the skills and the architecture files and things like that can be harnessed by AI. I think that's exactly the step, the next step that we can expect in this level of automation. I mean, like, it's not that even 20 years ago, I worked in Mellanox and hardware development. There were like specs all around, but you actually needed to know where to look for them, where to fetch them, pull them on time, etc. And I think that these days, like, tech leads and architecture can actually leverage AI even further, writing those and these like documents or rules and etc. probably going to be fetched more often by the coding agents, for example, by the AI code review tools, etc. So I actually think, like, if we go back to what we said like 10 minutes, 15 minutes ago, like, let's do more planning and designing, and sorry for the swearing here, specs, then, which is the best practice anyway. The same thing here. the more you write down in a AI native new world, make it a skill, make it like approachable to harness with AI, your job will be much better. And from the get-go, I love Dex what you said, is that we want those clean PR from the get-go. That's my feeling about it.
Yeah, I think I mean the cleanest way to put it is like the software engineering role hasn't changed much. It's completely different, but it also hasn't changed. It's like your job has gone to write high quality working code that scales and is maintainable and is evolvable over time, to produce high quality working code. You're not actually writing the code, but it's still your job to produce code, to ship, to do. I mean, I think it was Guillermo Rauch said this whole thing of like, yeah, shipping is different from coding. Coding is writing the program. Shipping is like getting it deployed, testing it, monitoring it in production, getting feedback, iterating on it, like making it really, really good. And all of that is like, you can automate parts of this. And you could wire up your support queue and your Sentry and your Datadog. You can like build this feedback loop where just everything that breaks goes back to a model and the model goes and ships it. The problem is like, I don't see a path to models being really good at software architecture. And you can do it with skills, and you can like bake those opinions into skills. But at the end of the day, like the thing that took like LangChain, CrewAI, all these frameworks that were in vogue 18 months ago, and like the gap between that and Claude Code is like reinforcement learning and like training the model on the harness it's going to run. And that was the first time you got really, really good, reliable, consistent tool calling. And you can RL a model. You look at like SweetBench and SweetBench Multilingual, like you can RL a model on getting the test to pass. You can RL a model on writing good code that solves a problem. What you can't RL a model on today, or what is like hard to like evaluate deterministically in a like reinforcement learning gym, is the code well architected? Is it designed well? The only thing you do there is ask another model, is it designed well? And that's super non-deterministic, and you could like bias it one way or the other. So I want to see, one thing we're working on, kind of toying around with at HumanLayer, is like a benchmark for like a long-term code maintainability, where like the test data set is like the model actually gets like 20 issues in it. It doesn't know the roadmap at advance. It's just like feature number 1, implement it. Like do that for like 20 features, and then hand that code base to a smaller, dumber model and see if that model can implement the 21st feature, and just see how it does. And then you see, okay, what does Codex produce after 20 features? What does Opus produce after 20 features? And then like to what extent, and then you run a SweetBench on both of those code bases to add another 3 or 4 or 5 features, and you have like challenges there. So like, I don't know exactly what it looks like, but I want a way to basically like evaluate, does this code get worse over time, and do models get worse at working in this code base over time, versus just these one-off, like here's a PR from Django, can the model reproduce it? So I don't know. That's what I'm excited about. I think that's what's coming next.
That's super exciting. I don't know if you wanted to say anything else, Itamar, but I realized we went over time, and I think that was actually a perfect way to wrap this up. You kind of hit like all of the points where we're headed, you know, what you're excited about, what you see in the future, what you guys are building and trying to test. So that was wonderful. Is anything else you'd want to add, Itamar or Dex?
Really enjoyed it. Thank you so much for coming to be in our show.
That was great. If you want to try our stuff, humanlayer.dev, we have a wait list up. We'll be launching in the next couple weeks. I know I've been saying that for a couple weeks, but it's actually freaking happening. So if you want to get hands-on with the crispy prompt or try our IDE, we're getting ready to give that to a lot more people. So if you want to learn more, please go check that out. I run a podcast called AI That Works, which has terrible SEO, but if you type a unicorn emoji and then AI That Works, you will probably find the podcast. That's awesome. That's the secret sauce. This was super fun.
Where do people find you most? I know this answer, but I want others who are listening to know this answer. Where are you yapping the most?
I yap the most on Twitter. Come find me on Twitter, twitter.com/DexHorthy. I'm sure we'll put it in the show notes or whatever. But yeah, come shout at me. Tell me what I'm wrong about. Tell me what you liked. Tell me what you hated. I love chatting and learning with the community here.
Love it.
Love it. Awesome.
Thank you.
Thank you.
If today's conversation challenged how you think about AI and code quality, that's the point.
At Kodo, we believe that independent, context-aware code review with rules as guardrails is how engineering teams maintain standards at scale.
If you're leading an enterprise team and want to see how intelligent AI code review can reinforce governance, visibility, and accountability in your workflow, visit Kodo.ai to learn how we help teams turn AI productivity into production-ready quality.
And if you enjoyed this episode, subscribe, share it with your engineering leadership circle, and leave us a review.
Until next time, keep human in the loop.
And keep shipping.